Okay, now remember, all right, I want everybody at the top of the page real quick. I want everybody to write down x, y equals 0. If x times y equals 0, can someone tell me what must be true? You are amazing. That is exactly right. That's called the 0 property. All right, if two things multiply together equals 0, one of them has to be 0. Either what? X has to equal 0 or y equals 0. Now, the significance of today is we can only solve equations that have a 1 as the power. Now, we're going to be able to solve all kinds of equations to the second power, to the third power, to the fourth power. All right, so we're just increasing our ability to solve things. All right, now again, I'm trying to tell some of you, and I'm not trying to give you a hard time. I'm trying to tell you, all right, if you can't factor, today's impossible. If you can factor, today is what? Easy. All right, so with that being said, all right, I'm asking about number 1, because these two things multiplied together has to equal 0, then one of those two have to equal 0. So that just means you write down 3x plus 1 equals 0, or 2x minus 5 equals 0. That's it. And now, of course, you just solve that. Now, again, I'm going to tell you what my expectation is. From here, everybody should be able to look at that and just say x equals what?
0.
Negative 1/3. Thank you. All right, x equals negative 1/3. All right. Now, how did I get that? I just what? Solved. Subtract 1 and then divide by 3. Right? It's just a basic equation. My 6th graders can do that. All right. Now, for the second equation, or x is equal to what?
Negative 5 over 2.
You guys need a lot of work. X equals what? No. Say it. 5/2. I'm not understanding where some of you guys are at. I really don't. All right? We're just solving a basic 2-step equation. You're isolating the x. To isolate the x, I do what? Add 5. And then what? Divide by 2. So the answer is 5 divided by 2, which is a fraction. All right, that's it. Anybody have any issues with that? On the first one, subtract 1, divide by 3, negative 1/3. That's it. That's all there is. Anybody have any questions? All right, so the rule is factor, set the factors equal to 0. So the only thing different between yesterday and today is after you factor, you set the factors equal to 0. That's it. That is all there is to it. All right. So again, some of the factoring can be tricky. So here we go. Let's look at number 4. I told you always look for a what? GCF. Thank you. Always look for a GCF. Is there a GCF here? Yes, there is a 2x. Thank you for whoever said that. There is, no, it's not 2x. It's 3x. Nice try, Rivers. All right. There is a 3x, common 3x. So everybody's putting down 3x, open parentheses. Now remember, the rule is divide and subtract. Divide numbers, subtract exponents. So what's 3 divided by 3? 1. And then x squared divided by x is just x. 6 divided by 3. So there you have it. And then you put equals 0. Now, how do I know I'm right? Well, because I did the problem number 1. All right. But number 2, I can always just check my answer real quick. What's 3x times x? 3x times negative 2. There you have it. Now, instead of just being done, we now set the factors equal to 0. 3x equals 0. x minus 2 equals 0. So the first equation, x, would just be, what is 0 divided by 3? 0. And how do I solve x minus 2 equals 0?
2.
X equals 2. So now, here is for me to make sure that you understand what I'm saying. If I let x equals 0 and I plug 0 in here and here, what's my answer going to be? 0. All right? I don't plug 0 in for one x and 2 in for the other x. All right? Now, someone tell me, what would happen if I would plug 2 in for x here and 2 in for x here? What would I get? Then I'm wrong. I would get what? All right, so I'm obviously not making sense. So here we go. Let's try. 3 times 2 squared minus 6 times 2. Does that equal 0? What's 2 squared? 4. 3 times 4 minus 12. 12 minus 12. What does that equal? Yeah, of course I'm right. All right. There are 2 answers. These are both answers. If I plug in 0, what am I going to get?
0.
If I plug in 2, what am I going to get?
0.
Those are the only 2 answers. In the past, we've only been able to find what? 1 answer. Now we can find what? 2 answers. All right. Now, believe it or not, there is a fundamental theorem of algebra. It says that the exponent tells you the number of solutions there are. All right. So the degree of this quadratic is 2. That means there's going to be how many solutions? 2 solutions. If you have an x cubed, there's going to be how many solutions?
3.
X to the 4th, how many solutions? 4 solutions. That is correct. All right. So it's just giving you a powerful tool to help solve equations now. All quadratics must be set equal to 0, and then they're factored. All right. Then you set the factors equal to 0. Then you solve the factors. All right. Straightforward, simple thing. All right. So now let's knock out number 7. Now, is there a GCF? No, but because we are brilliant, we can all now, and because most of you came up to my desk and said, yes, I understand everything, this is child's play now. All right, how do I factor that? Everybody should be able to look at that and just say, these are the factors. I've done it 150, 200 times now. What does that factor to? How's that, guys? Pretty good. Some of you, all right, some of you are sitting there still fumbling around. Why did you get negative? If you're still fumbling around with it, you can raise your hand and say, come on, I know we've been doing this for 2 weeks. I'm really trying to do better now. Help me. Everybody's good with that. All right, so now set the factors equal to 0. X minus 5 equals 0. X plus 4 equals 0. X equals 5, or X equals -4. And we're moving on. All right, check out number 9 now. I'm sorry, number 10. Is there a GCF here?
No.
No. All right, now we got a factor. Come on, do it yourself. 30 seconds. All right, here we go. First, I need to put down what?
2x and x.
2x and
And
x.
then -5,
-5. Someone said -4. Let's see if we're right. -5, -8 makes -13. Feels good. All right. Now, 2x minus 5 equals 0. X minus 4 equals 0. So now x equals what?
5/2.
Or x equals
4.
beautiful, beautiful, beautiful. That's it. Simple, simple, simple. All right. If you can factor what? Simple. All right, here we go. Number 13. Is there a GCF?
No.
No. So this one's kind of annoying. So here we go. All right, how do we start this guy? I'm going to start with 3x and 2x. Now, can I use 6 and 6?
No.
No. So let's try 9 and 4. Where would the 9 have to go? Where would the 9 have to go?
With the 2x.
With the 2x, right? Where would the 4 go? Let's see if that works. How much is that?
8,
How much is that?
7.
Does 27 and 8 make 19? Yes, it does. If the 27 is, and the 8 is, okay, now Max, I'm giving away all my secrets. You happy with that explanation? Confident, yes, or just let's go to the next problem? That's what I thought you would say. All right. Now, from there, all right, set the factors equal to 0. 3x plus 4 equals 0. 2x minus 9 equals 0. So now you just write x equals -4/3 or x equals 9/2. Somebody tells me what happens if I plug -4/3 in for x? You get 0. Thank you for listening. What happens if I plug 9/2 in for x? You get 0. Those are the only two answers that will make 0. All right. Here we go. The fun continues. Is there a GCF? Yes. Now listen, because there's no variable, here's what I want everybody to do. All right, there's no common x. I want everybody to go this. Now we're just going to do that once. All right, then from now on, I'm going to expect you to just divide out all constants if you can. Why do we do that? Because it makes the problem easier. So now, what do I get? X squared.
Minus 4x plus 4 equals 0.
Yes. Now how am I factoring?
That's max.
What do I got? 2 and 2 both negative. So now I want everybody to write this. Bless you. X minus 2 equals 0. Do I have to write x minus 2 equals 0 twice?
No.
No, because it's the same answer. So I want you to, I'm telling you right now, x equals 2. And then right next to it, I want you to write, it's called a double root. Root is the fancy word for I don't know why, but that's the answer. All right, they decided to call it roots. All right, roots also can be called a zero. These are just the different terms that mathematicians use to describe the solutions to a quadratic. It is a root. Sometimes they'll call it a zero. What? Where's the 3? No, or I would have done that. Dividing by 2 doesn't change it. Okay? All right, that's a pretty good question. All right, but no, if I divide by 2, it's still the same. If I plug 2 into the top equation here, what am I going to get? 0. If I plug 2 into this, I'm still going to get what? It doesn't affect anything. You with me? And let me explain why. Look up, because I appreciate you, William. Look right here. If I said 1 plus 2 equals 3, if I multiply by 2, I get 2 plus 4 equals 6. Is it still a true statement? Yeah. You see what I'm saying? So if I multiply everything through by 2, or if I divide everything by 2, I'm still going to get a true statement. The solution does not change. All right? That's a very good question, by the way. All right, here we go. 19. Uh-oh. What do I have to do here? Beautiful. X minus 5 and x plus 4. Notice I forgot the equals 0, so just add that in as I was typing. All right. And then you just say x minus 5 equals 0, x plus 4 equals 0. So X equals 5 or X equals -4, guys. It's simple, simple, simple. And again, I'm hoping someone who's having issues can say, just help me a little bit. Slow down a little bit. Tell me, good for you. Okay, that's what I'm saying. Please, I'm saying, now this is what I was trying to tell some of you. If you've done the 200 factoring problems, the factoring should not be a problem. All right, that's why some of you, and again, I'm not referring to you, but that's why I'm saying some of you guys are behind and you think I'm just going so fast because you haven't had the experience yet. And that's why when I posted the answers, it was easy. Yeah, we pulled another fast one on them. I just copied all the answers. And some of you are like, well, I just recopied it and put the picture up on my page. I know all that. All right, I know the games. All right, I played them all. All right, I don't, that's you killing yourself. All right, if you don't do the work, there's no escape work. All right, that's what being successful is. You doing your work. All right, and your future will be bright. All right, no shortcuts. All right, so with that being said, speak up, please. All right, I mean it. All right, don't be shy. Here we go. Uh-oh, 22, is that equal to 0? So now, I want everybody to look up here. X squared minus X minus 20 equals 0. Don't say, how did I do that? All right, look up. If you don't know what I did, think about it for a second. Is it equal to 0? No. So what did I do to the X? I moved it. What did I do to the 20? I moved it. When you move something, what do you do to the signs? You just change the signs around. That's how simple that is. It must be set equal to 0. All right, now let's get into the factoring. And what do I have? 5 and 4, -5, +4. And at some point, listen, for those of you guys who are brilliant, my teacher would get so mad at me, right? Because I can tell you what the answer is. I don't need to do all that work. I'm saying if you can look at that and tell me the answer, look at it and tell me the answer. You don't have to write X minus 5 equals 0. To me, that was a waste of my graphite. All right, I don't want to write all that work out. I can tell X minus 5 equals 0. I know the answer is what? 5. I don't have to write all that out. All right, that's what I'm telling you. I want you to see the math. All right, so if you are smart enough now to just look at that and say X equals 5 and X equals what? Then you're one step ahead of everybody else. And that's a good thing. So do I have to write X minus 5 equals 0? And some of you should. And some of you should. Because you're not quite there yet. All right? All right, let's check out 25. Oh, this one's a nice one. How many solutions? 4. Wow, because we're thinking. Good job. So now we're factoring this bad boy. Here we go.
X squared.
X squared what?
X squared minus 1 and X squared minus 9.
Wow. Who told you that?
Nobody.
Seriously.
I didn't.
Thank you. I knew that had to be the case.
Sorry.
All right, X squared minus 1. What does that factor to?
X.
No, because we're brilliant. We're just going to tell me what it is. No, stop talking. No, tell him, Tucker.
It's going to be X and X, and then it's going to
I know that already. I want the answer.
well, -1, -1 and 5.
Would someone tell him what the factors are, please?
1 and 9.
Stop. You're supposed to say X plus 1 times X minus 1. So then when I say, how do I factor X squared minus 9? You would say,
I said X plus 1.
no, you did not say that.
You just said X.
What am I doing with X squared minus 9?
You did X and X.
Stop talking, William. How do I factor X squared minus 9? Say something correct
Minus
today.
3 plus 3.
X minus
And
X plus
brilliant. X minus 3, X plus 3 equals 0. William, do you see your mistakes? That was plural, by the way. All right. So now, do I have to write all of that out? Do I have to write all of that out?
Yes.
No, we can just say, yes. Now, here's how mathematicians do this. What do you mean, what?
Keep going.
X equals plus or minus 1 or plus or minus 3. That accounts for all 4. Notice the plus on top of the minus means either 1 or what? -1. Now, I know some of you prefer, well, I don't like that. I'd rather do this. And that's okay. Do that. All right. It means the same thing. All right. Here we go. Let's knock out 28. What's the problem?
Equals -1.
It's not equal to 0. So what? Move the -1. So now we just say x squared plus 6x what? Equals 0. Yeah, 7 plus 1. Let's get out the calculator for that, Hunter. All right. Now what do we do? Here we go. We're factoring. Now, because we're great, don't tell me x and x anymore. Just tell me what the answer is. You should be able to visualize it now.
Both positive.
Thank you, Tucker. All right, I need the answers. Go ahead.
X plus 2 and x plus 4.
Yes, x plus 2, x plus 4. That sounds much better than saying x and x, plus and plus, 2 and 4.
And then x equals -2 or x equals -4.
And you can do a comma if you want. All right, that means x can be -2 or -4. And what now? Before, pay attention so you don't sound silly. If I plug -2 in for x, what do they equal? Thank you. They equal -1. How does it feel to be smart? It's kind of weird, isn't it? All right, here we go. That equals -1. Notice I didn't say equals 0. But if I said, what happens if I plug -2 into this equation here, what would it equal? 0. Because it says equals -1. How about that? Shh. I read the problem.
Plug it in.
Shh, shh. So I'm kidding you, Will. Look right here, bud. I'm telling you, these are the answers. Do you agree right here? So if I plug -2 in for x here, and then I add 7, my answer is going to be what? Right, because it says that's what it equals. If I were to decide to do something crazy, like plug these 2 into this equation over here, then it would equal what? Because it says equals 0. All right, here we go. Let's knock out 31. Oh, man. We got all kinds. Everyone put a star by 31. This is the one that's really hard because I can't just add 9. I cannot just add 9 because I don't have my quadratic. So again, this is the one that's hard. All right, so all I have to do is I have to multiply this out first. I have to multiply this out first. Now, look up on the board. Don't write it out. All right, look up on the board. All right, I'm expecting you to say that's just x squared plus 2x minus 8 equals -9. All right, that's what I want you to be able to say. Now, some of you are like, that's crazy. How did you do that? All right, so now let me teach you how we did that because I want you to be good with numbers. Look, it's not a mystery. All right, everybody knows how I got the x squared, right? That's just what? X times x. Now, to get the middle term, it's the smiley faces again. This is how much here? 4x. You're supposed to be able to hold 4x in your head at this stage of the game. And then I do x times -2. What's that? -2x. So now you're saying, okay, 4x minus 2x today is positive 2x. That's where that came from. And then what? 4 times -2 is -8. All right, does everybody see that? All right. I want you to be able to multiply numbers in your head, and not necessarily numbers, but that's called a quadratic. Multiply that quadratic. All right, so now I still have a problem because I want to do what? Set it equal to 0. So how do I set it equal to 0?
You add 9.
Add 9. So now I have x squared plus 2x plus 1 equals 0. Now, because we have a lot of experience, everyone should be able to look at that and say, okay, that's the most basic one. It's just what?
Oh, it's a double root.
Yes, it is. What is it?
-1.
I know. I don't want the answer. I want the factors.
X plus 1.
Thank you. X plus 1, X plus 1. So I want everybody to write down X equals -1. And then I want you to write, it's called a double root. I'm making you write double root because it's important in math. You don't need to know it necessarily right now, but in the future, your teacher will be talking to you about double roots and you'll know what a double root means. So now, pay attention. If I plug -1 in up here, what am I going to get?
Negative
I'm going to get -9. All right, if I plug -1 into this equation here, I'm going to get what?
negative 0.
0. All right, moving forward. All right, 34. All right, a little bit harder, but we got this. Factoring, 2 sets of parentheses. Let's go. I need a what and a what? 3x and x. And what am I doing with 8?
4.
And where do I want the 4 to go? 4 on the left. And somebody like, slow down. How are they doing that? Well, because he's done 150 problems and you haven't. All right, that's how he knows that. 4 is how much? And this is how much?
6x.
And I want negative. So
-6x.
I want the 4 to be what?
Positive.
And the 2 to be. Now, because we are brilliant, we now can say x equals
X equals -4.
and
Just 2.
yes, that's my answer. X equals -4/3 or 2. Everybody happy with that? Somebody tell me what time the bell rings.
57.
57? Okay, let's knock out 37 and call it a day.
Yeah.
All right, here we go. Give me some help.
2x.
Now, again, here's where experience comes into play. I quickly look at the middle term, and that's what? 11. And I'm looking at 4 and 3, and I'm trying to make 11.
Yeah.
It's negative, so it's 4x plus.
Right, so you're going to put the 4 with the 3 because that'll add up, or that will multiply to what? 12. All right, now again, I'm trying to give you a little heads up so you don't have to do it. All right, I want you to be able to say, instead of doing 2x and 2x, I'm recognizing I'm looking for 11. So if I put 4x and x, I want a 3 over here because that pairs up and makes what? 12. And now if I put a 1 there, now I need it to be -11. So the 3 is negative and the 1 is positive. All right. And now from there, we just say x equals, no, -1/4, comma, 3. All right, there you have it. All right, now again, guys, I feel really good. All right, and hopefully you're not sitting there going, man, he is crazy. All right, I agree. I'm not discussing that, but I'm saying, you guys, it's just practice. If you don't, you can't do it. All right, this is super important. When you're sitting taking calculus, you'll be factoring. All right, you have to know how to do it. All right, that's why there's so many problems these last couple days. All right, I need you to do that. All right, now you're allowed to take the weekend off. I'm not giving you homework. When we get back now, we got, and if you're struggling, going, oh my gosh, I'm having a hard time, instead of taking 4 days off, work for 4 days on your math. That's not a crazy thought. I know some of you are like, he's crazy. No, if that's what you need to be smart, that's what you should be doing. All right? If you want to be average and you're struggling with math, then don't do anything. All right? But no one's average. All right, get the problems done. All right, the end. Good job. Turn on the lights, please.